Hello, welcome to F-Grade Electronics, where we try to fix broken electronic devices. This is another R7 374 gig from Sapphire. I don't know what's wrong with it. That's why I'm going to disassemble it first. Looks like the washers are molten and some are missing. I think some caveman tried to cook this graphics card. Yeah, these two washers are molten and we have a missing one here. Yeah, this one is also molten, and we have the wrong screws in these places. Yeah, looks like the previous, I don't want to call it technician, the person who attempted a fix before me was a real professional, it looks like, by looking at the status of this card, the situation here. Okay, we have the fan out. Is this even thermal paste? What is this? Is it brown? I don't know. Hope it's not gore. Okay, let's also take this thermal pad. Let's measure some resistances. First, in diode mode, I want to check the fuses. We have one here. This one is all right. Let's check the fuse for the PCI Express slot. It's also fine. Let's check the 12 volts. Here also. They look all right. Let's check the 5 volts. Looks fine. In ohms range, let's check the core. Around 9 ohms. This is a little bit high, but it's not shorted. Let's check the packs. Around 200 ohms. We saw that it's normal for this card in the last video. Also, let's check the memory. 113 ohms. Okay, what kind of memory this one has? This is also LPDA. It was a little bit higher in the last video, but it's not shorted or anything. I think this is healthy. Let's also check VDDCI. It's 100 ohms. Okay. Let's check some voltages then. The card is connected to a computer through a riser cable. Let's put the meter in voltage mode. And I also plugged a display cable here to see whether we are going to get a display or not. I'm going to probe ground from here, the shroud. Okay, let's turn the computer on. It's on. Let's see, do we have vehicle? Yes, we do. Do we have memory? I'm going to check it through the inductor here. Yes, we do. It's 1.5 volts. The motherboard is giving out a RAM error, but we can check the voltages without the computer booting. Okay. Are all the voltages gone now? Okay. Let's check the VDDCI. Okay, we had it, but now we don't. Okay, we have it. Let's check packs. We have packs. We should have 5 volts then. Okay, all the voltages look alright. Let's plug the card onto the PCI Express slot and try to see whether it's initialized in Linux. Here we have our test board, and I'm going to plug the graphics card, the partially reassembled graphics card, into the 16X slot. Let's connect the external power and the HDMI cable. Now it's directly connected to the graphics card. Let's turn the power supply on and turn the motherboard on. Okay, it's on now. Let's watch. We heard the beep, but we have no picture. Let's turn it off. Now I'm going to use the 4X PCI Express slot on the motherboard, not the full 16X slot. This one is not directly connected to the CPU. It's connected to the chipset and then the CPU. Let's turn the computer on again. The fan stopped because of different hardware. It stopped again. And now look at this. We have picture. Let's turn it off again. I'm going to plug my T-server USB the motherboard, and let's turn it on again. It's in the second slot, the X4 slot. And let's run a T-server test. ls PCI. We have our graphics card right here. The test is running. Okay, the test is finished. And we have no errors. Yeah. Let's turn the computer off. It's off now. As you can see, the card passes the memory test. Let's try putting it in the x16 slot again. Turning the computer on. Yeah, check the CPU fan. Now, while the card is in the 16X slot, I'm going to plug the HDMI to the motherboard, to the iGPU, and we have picture. Let's boot to the Linux again. And ls PCI. We have no graphics card. Okay, I'm going to turn it off and put the card on the bench again. We have the card on the bench again. Let's also remove the cooler. And also, let's remove whatever this is. Okay. Let me tell you what I did off camera. Plastic thingy. Moment. Okay. Let me tell you what I did off camera. I flashed the BIOS on this card It didn't do anything, but I did it anyways because it was easy to do. I did it on Windows using ATI Flash or AMD VB Flash, however you want to call it. I reflowed the capacitors here. Let me tell you why I did that. Let's get our multimeter and put it in diode mode. Let me show you. These capacitors on this end are connected to the GPU core directly. And you can see a diode value. This is the last pair, the 16th one, the 15th. Yeah, this is the 8th one. And we can see a value, a very similar value, only 1 or 2 millivolts off. That means on this end, it goes to the GPU. There's no problem. And then it's connected to the PCI Express slot pins. I also checked them. I'm not going to test from number 1 to number 8 because I also tested this card on my Xeon system, the X58 one, and it gave a picture. I was able to boot into Windows. I saw the X8 link in GPU-Z, which means the first 8 pairs are all good. But from 9 to 16, we have a problem. That's why, let me tell you how it works first. The GPU, actually the motherboard, sends a signal to all pairs, and if it receives a signal back from all 16 lanes, the handshake happens and GPU runs at x16 mode. If only 8 lanes are present, the handshake happens at x8, or the physical slot has only 4 pairs and we put an x16 graphics card into the x4 slot, and only 4 data lines receive a signal. The GPU outputs using only 4 pairs, and the handshake happens at x4. But let's say we have a problem with the 10th pair. All the other 15 pairs output a signal, and the motherboard can't think there's a problem, and the handshake doesn't happen. And this happens, the card does not initialize, and we don't see it in Linux as we checked before. The camera stopped recording. Now I'm back. Okay, where were we? Yeah, there are 2 possibilities for this problem. Either the data line in the GPU chip itself is broken, or the connection here is broken. The signal passes through these tiny capacitors. These are LVDS capacitors, low voltage differential signal, and they let the alternating signal pass, but it blocks DC. That's why they're here. If one of them is broken from the 9th to 16th lane, the motherboard won't be able to detect the card. It's going to try to detect, but the handshake is never going to happen. Sometimes it happens, it depends on the motherboard actually. I saw it happen before. But we are definitely sure that one of the lanes is broken. These are 220 nanofarad capacitors or 0.22 microfarad capacitors. They aren't polarized. The plus or the minus is not important for these type of capacitors. I am going to use a donor board like this one and extract the capacitors here and put them right here. Let's start by removing the capacitors from the donor card. I'm first going to apply some flux. And we are going to remove them with ATE. It's going to take some time. Okay, now we have more than enough. I desoldered some more than needed. We need 16 capacitors for 8 pairs. But these fly away, get lost all the time. That's why I extracted some extra. Now I'm going to desolder the last 8 pairs from the board. I have a big tip. I can touch both sides of the capacitors with a tip like this. And desolder them easily. One, two, three, four, five, six, 7 and 8. Okay, we desoldered all of them, all the 8 lanes. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we are fine. Let's apply some flux now and thin the pads. We're going to be able to see if any pads are broken by thinning them. If they are not shiny and the solder does not stick to the pad, that means there's no pad there. Okay, oh, looks like all 16 of them are shiny. Let's clean the board. Now, if we plug the card like this to the x16 slot, it's actually going to work. Because there are no lanes anymore. There will be no signals going through and coming from, going to the GPU and coming from the GPU. That's why it's going to work at x8 mode, but it's going to work no problem in an x16 slot. But in x8 mode. Okay. Now we are going to resolder the capacitors one by one. I'm going to change my soldering tip to a much thinner one, and we are going to solder our new capacitors one by one. The soldering iron is heating up. We are going to apply some flux first, a tiny amount, and we are going to solder each capacitor, 16 in total. Now we can apply some flux and reflow the capacitors with some hot air. Okay, let's clean the board while the board is still hot. I put the card back in the computer and did the same test as before. The results were the same. There was no picture on the x16 slot, and the x4 slot was doing the same. The card was passing all the tests. I decided to remove all 8 capacitors first to run the card at x8 mode in the x16 slot. But then I did something else. Let's continue watching. Here we have the card again. It's an x16 slot. Let me tell you what I did. I took the card again and took my soldering iron. I just touched each end of each capacitor one more time. I wasn't hopeful that it was going to do anything. Let's put the card in the x16 slot. On the power supply on. And I'm also going to plug in my thumb drive. Okay, let's turn down. And we have a picture. Let's run memory test. We have the results and it's a pass. No errors or anything. Let's turn it off. Yeah, looks like we have another card fixed. I'm going to clean it and test it on Windows, but I'm going to do it tomorrow because It's too late. I need to sleep. And I'm going to come back with a fresh voice tomorrow. It's going to take just a second, like this. We have the card in the 16x slot, and I was trying to boot into Windows, and then when the Windows was booting, red stripes appeared vertically on the screen, and then Windows just froze. That's why we are going to do a T-server test. The card is not able to output a picture. That's why we're using the integrated graphics now. Let's turn the computer on. Like I said, the picture is from the integrated graphics on the CPU. The fans are spinning. That's a good sign. Let's go into Linux. Let's type ls PCI. Yeah, we have the card right here. The card is initialized, so we can run the test. The previous problem is gone. The card is detected in the PCI Express x16 slot. Okay, we have the report. Checking the report, we can see we have a problem with channel A. The first chip. It's weird. Only 1 bit here, then 8 bits right here. But we are going to replace it anyways. If it was like only 1 bit, I would think a solder ball is cracked or something like that, but we have more than 8, actually 9 bits with problems. That's why I'm going to replace the chip. The card is disassembled and is on the bench. Channel A is this one, A, B, C, D, E, F, G, H. We are going to replace this one with this chip. This is an LPDL. W4032BABG. I have the same chip rebuilt right here. I'm going to replace this one with this one. We need to first take the chip off the board, but I'm going to use some aluminum tape to protect these capacitors from the hot air. Okay, let's apply some flux on the sides of the chip and start heating it. Yeah, the chip is off. We need to clean the solder from the card while the card is still hot. Okay, it's dry now. Let's apply some flux. You don't want to apply too much because too much flux can bubble and create a solder bridge between the balls. Okay, we have the arrow here, and the arrow should match the dot on the chip. Let's align it. Yeah, it looks all right. Let's apply heat. It's still a little bit hot. I'm going to wait, and when it's warm, I'm going to plug it to the computer and run the memory test again. The card is in the PCI Express slot again. Let's turn the computer on again and run a memory test. The test is done. Let's check the results. Yeah, we have no memory related problems then. It's time to reassemble the card then and try it on Windows. The card has been running per mark for around half an hour. It's running toastier than I would expect. It's running at 84, 85 degrees Celsius. It's a little bit hot, but it won't cause a shutdown. I tried repasting it, but it didn't help. Now I want to also run a superposition benchmark test. Yeah, let's do it 1080p high. Okay. The test is over. The card is running like it should. It's a little bit on the hot side, but it doesn't crash or something like that. And also, let me show you that the GPU is running at x16 mode can be seen here at x16. Yeah, the card is fixed. It had a problem with the LVDS capacitors and VRAM. We had to change the VRAM on the A channel. Thanks for watching. If you liked the video, please hit the like button. If you have any questions or suggestions, please write them in the comments. Yeah, see you again in the next video. Goodbye.